So good evening everyone and welcome to my live stream. So today we are going to discuss ACF by prime factorization method, and in the later part of the stream we will cover one more topic, that is continued division method. So what is ACF? Let us discuss first. ACF is highest common factor. Highest common factor. Now we know what are factors. Factors are numbers by which we can completely divide any number, is it? So let me first explain what are factors. Suppose factors of, I'm taking small numbers, factors of say 6. So what are the factors of 6? 1, 2, 3 and 6. This means that we can divide 6 by the numbers 1, 2, 3 and 6 without leaving any remainder. Okay. Now say factors of 8. Factors of 8 are 1, 2, 4 and 8. So we can divide 8 by all these numbers without leaving any remainder. Now if we are to find out the common factors between 6 and 8, so we can see we have 1 and we have 2 as common factor. Okay, so in that case our ACF will be 1 into 2 equal to 2. That means between 6 and 8 we have 2 as the common factor. So we call it the highest common factor. Okay, now this is the very basic method of finding the ACF. Now what if the numbers are 2-digit number or 3-digit number? We cannot afford to find the factors one by one. In that case we can use prime factorization method. And like I said, in the later part of the stream we will discuss one more method. So let us take an example and then understand. So while I am writing the example, may I request my viewers to please like my stream. Your one like gives me a lot of encouragement. So I would request all of the viewers to please like my stream. Example, find the HCF. So I will be writing ACF, okay? I won't write highest common factor again and again. So find the ACF of 144 and 192. Okay, now as the name is suggesting, ACF by prime factorization method. So what are prime numbers? So prime numbers are the numbers which have only two factors. That means these numbers are divisible by only two factors. For example, 2. 2 is the smallest prime number and 2 is the only even prime number. Apart from 2, all the prime numbers are odd. So 2 has two factors, 1 and 2. 3 has two factors, 1 and 3. 11 has two factors, 1 and 11. So these type of numbers, they fall under the category of prime numbers. So in this method we are going to use only the prime numbers. So what we'll do, we will divide, or rather we'll start dividing 144 by prime numbers. We cannot use any other number in this particular method. So what is the smallest prime number? The smallest prime number is 2. So we'll write this in a kind of this format. So when we are writing in this format, it means that we are dividing 144 by 2. Okay. So what is 144 divided by 2? This is 72. Okay. Now we will keep on dividing by 2 till the point where the number is not, or the number becomes such that it is not divisible by 2. by 2, sorry. So 72 is very much divisible by 2. So 72 divided by 2 is 36. 36 is also divisible by 2. This is 18. 18 is also divisible by 2. 18 divided by 2 is 9. Now 9 is no longer divisible by 2. So what is the next prime number in the list? 3. So is 9 divisible by 3? Yes, very much. So we will divide it by 3, and this is 3. So 3, again 3 has to be divided by 3 and nothing else, so we will keep it in this way. So these are all the prime factors of 144. Now same will be done for 192. Okay, so the number ends with 2, so this is divisible by 2. 2 into 9 is 18, and 2 into 1 is 2. Okay, now what? Did I make a mistake? Yes, this is 96. Sorry, extremely sorry, this is 96. Now 96 is again divisible by 2. 2 into 4 is 8, and 2 into 8 is 16. Is it? Then the number ends with 8, so this is divisible by 2. 48 divided by 2 is 24. 24 ends with 4, so this is divisible by 2. So this is 12. 12 is divisible by 2, it gives us 6. And finally 6 is divisible by 2 and 3. And 3 is divisible by 3, so we will stop our prime factorization here. Now what we'll do, we will list the numbers or the factors. So we can write 144 rather, as 2 multiplied by 2. That means we will write all the factors into 3 into 3. And likewise we will write 492. Okay, so 192 is, how many 2's are there? 1 2 3 4 5 6. Okay, 1 2 3 4 5 and 6 and 3. Now let's see what are the common factors among these. So I am just writing them inside an oval. Okay, so this is one common factor, this is 1. Okay, so the 144 doesn't have any more 2's left, so now we can take the 3's. 192 has only 1 3, so yes. Okay, so then what will be the ACF or the highest common factor of 144 and 192? So we'll write all these factors. So we'll write 2 into 2 into 2 into 2 into 3. So 2 into 2 into 2 into 2, 16 multiplied by 3. So what is 16 multiplied by 3? 16 multiplied by 3 is 48. So the highest common factor of 144 and 192 is 48. Okay, so this is how we find highest common factor by prime factorization method. Okay, so we'll try one more example. Let's take 3 numbers and then find the ACF of them. Or let us do one more, then we will proceed for finding out ACF of 3 numbers. Okay, so I'm shifting to a new page and let me adjust my book. So meanwhile, may I request my viewers to kindly like my stream. Your one like equals to one encouragement for me. I hope this is visible. Yes, much. So find the HCF of 225 and 450. Okay, so we will do a prime factorization very quickly. So we have 225. Now, as per the rules of divisibility, the number 225 ends with 5. So this is not divisible by 2. So next, what is the prime number after 2? We have 3. So is 225 divisible by 3? Yes. I mean, for grown-up students, they can just have a look and say whether this is divisible by 2 or not, right? But when uh, students of say 5th or 6th standard, what they can do, they can use the test of divisibility. Now, how to check whether a number is divisible by 3 or not? You can just add up all the digits. So we have 5 plus 2 is 7, and 7 plus 2 is 9. So 9 is divisible by 3, that means 225 is also divisible by 3. Okay. So let me see if possible I can explain the tests of divisibility in some other video or live stream. Okay, so we'll start dividing it by 3. So 3 into 7 is 21 and 3 into 5 is 15. Okay, so is 75 divisible by 3? I mean, most of the students, they make a very common mistake. As soon as they see 5, they will start dividing it by 5. But as per the rules, you have to start dividing by the smallest prime numbers. Okay, so don't just jump into dividing the number by 5. So this is divisible. 7 plus 5 is 12, and 12 is divisible by 3. So I will divide it by 3 once again. Now 25 is no longer divisible by 3. 5 plus 2 is 7. So this is divisible by 5. So I will write 5 and 5. Okay, so this part you can just cut it. Okay, so these are the prime factors: 3, 3, 5 and 5. So let's take 450. So 450 ends with 0. So this is divisible by 2. I mean, any number ending with 0, 2, 4, 6 and 8 are divisible by 2. This is what we have learned. So we'll divide it by 2. 2 into 2 is 4. 2 into 2 is 4. And 2 into 5 is 10. So as you can see, we have just got the same number, 225. So without thinking much, we can write down the factors as it is. Okay, so that is what we'll do. So we will simply write down all the factors. So 3, then we have 75, then 3 and 25 and 5 and 5. Okay, so we are done with finding out the prime factors of 225 and 450. So we'll write 225. So we have 3 into 3 into 5 into 5, and we have 450. So we will write 2 into 3 into 3 into 5 into 5. Okay, so how many factors we have in common? So except these two, we have all the factors which are common. We have 3 here, 3 here, 3, 3, 5, 5, 5, 5. So HCF of 225 and 450. If you want, you can mark the factors also, no issue. So this is a 3 and 3 in common. This is another 3 and 3 in common. Then 5 and 5 are in common. 5 and 5 in common. This looks like a peanut. So this is 3 into 3 into 5 into 5. So 3 into 3 is 9, 5 into 5 is 25, and 25 into 9 is 225. So the ACF of 225 and 450 is 225. Okay. Okay, so we'll try one last question using prime factorization method, and then we will learn the continued division method. In fact, that method is, if anyone asks my opinion, that continued division method is easier than prime factorization, although this looks easier. Okay. So find the ACF of 84, 120, 138. So we have three different digits. Okay, so let's start the prime factorization. And along with that, may I request my lovely viewers to please like my stream. Okay, so this is very much divisible by 2. 2 is the smallest prime number. So 84 divided by 2 is how much? 42. 42 is again divisible by 2. So 42 divided by 2 is 21. 21 is no longer divisible by 2. So I have to divide it by 3 and 7. So I can cut this part. So these are the prime factors of 84. Next, 120. So 120 divided by 2 is 60. 60 is divisible by 2. So 60 divided by 2 is 30. 30 is divisible by 2. So we get 15. And 15 is divisible by 3 and 5. Okay. And lastly, 138. So we'll start by 2. 2 into 6 and 2 into 9. Is it? Yes. So we have to divide it by 3 because this is not divisible by 2 anymore. I mean 69. So we'll divide it by 3. 3 into 2 is 6 and 3 into 3 is 9. And 23 is a prime number. So we cannot divide it by any other number. So our prime factorization will stop here. Right? So we'll write, So we'll write factors of 84. Or I will just cut this part. We will simply write 84 is 2 into 3 into 7. Then we have 120. So 2 into 2 into 2 into 3 into 5. Okay. And then we have 138. So 138 is 2 into 3 into 23. So we can see we have a 2 which can be taken as common from both the numbers, and then we have 3 and nothing else. That means we have a 3, 3 and 3. Okay, so we will write therefore ACF, is this part visible? Yes, very much. ACF of 84, 120 and 138. So what will be the ACF? 2 into 3 equals to 6. Okay. So this is how we do prime factorization for finding out the highest common factor. Okay. So next up we have continued division method. Okay. sometimes what happens, here the numbers were very small in value, right? 225, 450. Sometimes you may get numbers up to 3 digit, 4 digit also. Okay, so in that case, this continuous division method proves to be very useful. Okay, so I will turn to a new page. So this continued division method is also sometimes known as Euclid's method, because this is basically a derivation from the Euclid's algorithm, division algorithm. Okay, now let us write one example and solve. The name itself is suggesting what we are going to do. We are going to do division and we will continue our division. Our division doesn't end when we find the remainder. That is the essence of this method. So find the HCF of, find the HCF of 513 and 783. Okay, now how to do the continued division? So what we'll do, we will divide the bigger number by the smaller number, as simple as that. Okay, so 783 divided by 513. So 513 multiplied by 1 is 513, and let's just check for verification what is 513 divided by 2. So this is 26 and this is 10. So this is 1026. So 1026 is way greater than 783. So what we'll do, we will write 1 as the quotient, and then we will write 513 into 1. This is how much? 533. 513, sorry, and 7 and 2. So our normal division ends here. We get the remainder 270. But as the name is suggesting that we are going to continue our division, so what will happen at this stage? The remainder 270, listen carefully, okay? The remainder 270 will become our new divisor, and the previous divisor, it becomes our new dividend. So what will happen? So this is 513. So at this point, so did you see the previous divisor now became the dividend and the remainder became the divisor? Okay, so 270 into 1 is obviously 270. So what is 270 into 2? Just check it for once. We'll check it. 540. So we have to take 270 into 1. So 270 into 1 is 270. So we will continue this division until, as long as our remainder is not 0. So 3 minus 0 is 3. 11 minus 7 is 4, and this becomes 2. 2 into 2 is, sorry, 2 minus 2 is, 4 minus 2 is, I beg your pardon, 2. So we have 243. Now again we'll continue. So our remainder becomes the divisor, and the divisor becomes the dividend. Okay, so 243 into 1 is 243. Okay, so 10 minus 3 is 7, and this becomes 6. 6 minus 4 is 2. So now we are going to divide 243 by 27. So we can just check it. I mean 27 into 10 is 270. So let's check it with 9, because this seems a large number, is it? So 227 into 9. 9 into 7 is 63. And 18, 19, 20, 21, 22, 23, and 24. Yes. So at this point, our remainder becomes 0. Okay. Now we have completed our division. Now what will be our HCF, or the highest common factor? The point where the remainder becomes 0, we have a divisor. So this divisor becomes the HCF of the two numbers. Okay, let me repeat it. The point where the remainder becomes 0, the divisor becomes the HCF of the two numbers. Okay, so HCF of 513 and 783, you may write is, or I am writing equal, how much? 27. Okay. Now why this method is I mean say superior in a way than prime factorization? Because sometimes in prime factorization method, after repeated division, we may come across some prime numbers. Now it is not possible for us, no, to remember each and every prime number. So at that point we may get stuck at that point, and I mean in our exams our time is very limited, right? So at that point, in fact, I always suggest my students, unless and until it is mentioned in the exam that use prime factorization, I always advise continued division method. Okay. So I hope this is clear. We'll do few more examples. Let me adjust my notebook. And may I request my viewers to please like my stream or share it with your friends. Let me just choose one question. In case you are wondering, I am using a book from 6th standard. Okay, so this is the book I am using. Okay, because these things are initially taught in 5th or 6th standard, so I am using a book which is used in class 6 or class 5. So let me write one more question. Find the HCF, or the highest common factor, of 216 and 1176. Okay, now 1176 is a huge number, right? 4-digit number. So if we happen to do this with prime factorization, just imagine how much time it is going to take, right? So in this case, this method proves to be very useful. Okay, so let's start our division. 1176 divided by 216. So So Chandragupta Sharma says, thanks, sir. Thank you, Chandragupta Sharma, for joining my live stream. I would request you also, if you are new to my channel, please subscribe it. Or if you are already a subscriber, thank you so much for being there. So 216, how much? Should we take 5? Let us check with 5. 5 into 6 is 30. 5 into 1 is 5 and 3, 8 and 1080. Let us check one more. Into 6. 6 into 6, 36, and this is 9, and no, this is 1296. So we will take 5. 5, and this is 1080. So 6 minus 0 is 6. This is 17. 17 minus 8 is 9. Okay. So our remainder is 96. And this remainder now, in the second step, this remainder 96 will become the divisor. And this divisor 216 will become the dividend. 216. So 96. Let us check it with 2 and 3. 6 into 2 is 12, 18 and 19. I think this should do it. 96 into 3. No. 9 into 3 is 27. So we have to check it by 2. 2 and 192. So 6 minus 2 is 4, and 11 minus 9 is 2. So we have 24, the remainder. Now this remainder will become the divisor for the next step, and the 96 will become the dividend for the next step. So 96. So I think we have arrived at the answer, because 24 into 4 is 96. Is it? 16 and 9. Yes. 24 into 4 is 96. Now at this point our remainder is 0, and when the remainder is 0, when our divisor is 24, that means the HCF of 216 and 1176 is how much? 24. So see how easy this method is it? But the thing is, if you make a mistake while dividing, then no one can help. Okay, I just wrote the previous question. HCF of 216 and 1176 equals to how much? 24. Okay. So we have been streaming now for how much? For 35 minutes, is it? Okay, so we'll try to do few more questions. We'll try, I will do one more question, and then we will find out the HCF of 3 numbers. Okay, we'll do one more, two numbers. Let me just choose one question. Okay, this time let us take one 4-digit and one 5-digit number. That will be fun. I'm just turning to a new page, and let me adjust my notebook. Find the HCF of 3192 and 14,280. Okay, now just imagine if you were to do prime factorization on these two numbers, how much time this will take. Okay, So is this visible? Let me adjust. Yeah, this is visible very nicely. So shall we begin? Okay, let's wait for some users to join and then we will begin. Camera to bar focus হৈ থাকে ন, out of focus হৈ থাকে। ঠিক আছে, আৰম্ভ কৰোঁ তেনেহ'লে। সো ইয়াত কি আছে আমাৰ 14,280 আছে হয়নে, 14,280। তো ইয়াক আমি কিহেৰে ডিভাইড কৰিম, ইয়াক আমি কৰি চাওঁচোন। এতিয়াতো বৰ্তমান 3192 আছে, তো 3192 দিয়ে চেক কৰোঁচোন। এনেই চাব গ'লে কিমান 3 into 4 12 হয় ন, আৰু 3 into 5 3 into 4 হ'লে 12 হয়, 3 into 5 হ'লে 15 হৈ যায়। তো এবাৰ 3 into 4 কৰি চাওঁ। তো 4 দুগুণ 8, 4 9 গুণ 36, 4 5 6 7 আৰু 12 হয়নে। 4 into 2 8, 9 into 4 36, 7 অ'কে। চ' কিমান আহিছে 12,768 আহিছে হয়নে। তো এইটো ইয়াত 4 হ'ব, ইয়াত 12,768 হ'ব। মাইনাছ কৰোঁ এতিয়া বঢ়িয়াকৈ। 10ৰ পৰা 8 গ'লে 2 হৈ যাব, এইটো 7 হৈ গ'ল, 7ৰ পৰা 6 গ'লে 1 হৈ গ'ল, এইটো 12 2 আছে তাৰমানে 12, 12ৰ পৰা 7 গ'লে 5 হৈ গ'ল, আৰু 4 আছিলে এতিয়া 3 হৈ গ'ল, 3ৰ পৰা 2 গ'লে 1। তো কিমান হ'ল 1512, 1512, 1512। চ' এতিয়া এই 1512 ৰিমাইণ্ডাৰ আছিলেতো, এতিয়া ই হৈ যাব ডিভাইজাৰ। ঠিক আছে, আৰু এই যোনটো 3192 আছিলে 3192, এইটো এতিয়া হৈ যাব কি হৈ যাব, এইটো আমাৰ হৈ যাব এতিয়া ডিভিডেণ্ড। ঠিক আছে, তো এতিয়া 1512 দি চেক কৰি চাওঁ। 1512 এনেইতো চাব গ'লে 15 into 2 হ'লে 13 হয় জানো, হয়নে। তো 2ৰে কৰি চাওঁ কি হ'ব, এইফালে হৈ যাব 24, এইফালে 13, ধুনীয়াকৈ হৈ যাব। ইয়াতকৈ যদি মই 2 নলয় 3 লৈ লওঁ নহয়, তেতিয়া কি হ'ব, এইটো 15 3 গুণ 45 বেছি হৈ যাব ভেলিউটো দেই। তো আমি 2তে থাকোঁ, কিমান হৈছে 3 0 2 আৰু 4। 12 আছে, 12ৰ পৰা 4 গ'লে কিমান হয়, 12ৰ পৰা 4 গ'লে 8, এইটো 8 হৈ গ'ল। 8 minus 2, 8 minus 2 is 6 and this is 1, so we have 168. okay, so 168, so 168 আছে এতিয়া, this 168 becomes the divisor for the next step, okay, and this 1512 will become the dividend for the next step. Now let's check for 168, 168, I think I should check with 9. If not 9, then we'll check it by 8. 8 into 9 is 72. 54, 55, 56, 57, 58, 59, 60, 61. 54, 54 আৰু 61, yes. And 9, 15. Oh, very nice. So I was not expecting the division to end here, but nevertheless we are happy because our HCF is now 168. Remember, whenever the remainder becomes 0, at that point whatever the divisor is the HCF of the numbers. Okay, so since the remainder has become 0 and at this point our divisor is 168, so HCF of 3192 and 14,280 is equal to 168. Okay, so let's try a few more questions. So while I am writing the question, may I request my lovely viewers to please like my stream. Like my stream, subscribe to my channel, and help me in every way possible. I will be so grateful to you. So let's find the ACF of 399 and 437. So 437 divided by 399. So obvious, 399 into 1 is 399, and if we multiply it 2, this will be somewhere around 700 something. Okay, so let's take 1. 399 into 1 is 399. 9 minus 9 is 0. 13 minus 9, 4. Okay, so we have 40. Okay, so whatever the remainder is will now become our divisor, and whatever our divisor was will become our dividend. So we have 399. So 4 into 10 is how much? 400. So we are just one shy of 400. So we have to take 9. So this is 360, because 9 into 4 is how much? 36. Okay, so 39, and our new divisor, new dividend will be 40. So 39 into 1 is 39. Remainder is 'I think I have to do it once again because I have made a mistake. So I am really sorry. I will just write the question in a new page. We'll find the ACF of 399 and 437. So let's start our division. 437 divided by 399. So it's very obvious, this will be 1. 399 into 1 is 399. So 17 minus 9 is how much? 8. So if you can just give me 2 minutes, I will be right back. Okay, so now I am being attacked by a swarm of insects. So it's nearly sundown here. I hope my stream doesn't get affected by the swarm of insects. Anyways, let us continue. So 17 minus 9 is 8. Okay, and then we have 12. 12 minus 9 is 3. So this 38 is now our okay. So 38, which was our remainder, is now our new divisor, and the 399, which was our divisor, is now our new dividend. Okay, so now in this part now you cannot, I mean, don't go for dividing the number 399 at once. Okay, because we have, if you notice the first two digit numbers 39, so 39, I mean 38 into 1 is 38, is it? So we can write 31 into 1, 38 into 1, which is 38, and then 19, I mean this 9 will come here. Okay, so now what is the new number? 19. Is 19 divisible by 38? No. So if it is not divisible, we will put a 0 here. Is it? So the next, I mean the 19, which is now a remainder, will become the new divisor, and the 30th, which was our divisor, will become our new dividend. So badhai ho, 19 into 2 is 38. So 19 into 2 is 38 and our remainder is 0. So our continued division ends here. Is it? At this point our remainder is how much? 0. And when the remainder is 0 and our divisor is how much? 19. So the HCF of 399 and 437 is how much? 19. Oh, okay, so the HCF of 399 and 437 is how much? Is 19. Okay, so we will, it's already 54 minutes, so we'll do very quickly, we'll do one more question and then we will wrap up today's stream. Let us try to find the HCF of three numbers. Okay, if possible I will plan few more live streams on the topic HCF and LCM. Sometimes what happen, we, I mean in the race of learning complicated things, we tend to forget this small things. Okay, so it is, I mean, crucial that we keep ourselves in touch with these topics as well. Okay, so that is my main idea of, because sometimes my students complain, so why are you teaching these basic things? We need to learn the, I mean, sums of class 9, class 10, class 8, but sometimes in the process of learning those things we forget these very basic things. Okay, and if you have noticed in recent times, these type of questions do come in the competitive exams, because the question pattern of competitive exams are what? Mathematics of primary school. So, so you, I mean, you cannot afford to forget all these things. At some point of your career, you will have to use these applications. Okay, that is why. Find the HCF of 624, 936 and 264. Now when we have three numbers, how to do? So what we'll do, we will pick any two numbers. Okay, so in this case we will pick 624 and 936 and we will repeat the same continued division process. Let us do first and then I will show you what to do next. So that means first we are targeting these two numbers. We are finding the HCF of 624 and 936. Okay. So while I am finding out, may I request my viewers to please like my stream. Okay. So 6 minus 4 is 2, 3 minus 2 is 1 and 9 minus 6 is 3. Okay, our remainder is 312. So this remainder now becomes the dividend. So just give me 2 minutes, I will be back very quickly. So let us continue. So our remainder was 312. So this remainder is now our new divisor. Okay, and this new divisor, old divisor, is our dividend. So let us check 312 into 2. So this is 624. Okay, nice. So our first division ended in just 2 steps. Okay, so ACF of 624 and 936 is 312. Okay, now our ACF is 312 and the number which is left is how much? 264. So we'll repeat the same step for 312 and 264. Okay. 264 into 1 is 264. So 12 minus 4 is 8 and 10 minus 6 is 4. So 48 now is our divisor and the divisor 264 is our dividend. So 48 into how much? 6 into 8 is 48, 24, 28. Let's check it with 5. 48 into 5. 5 into 4 is 5 into 8 is 40, 20, 24. 5. So 5 into 4 is 20 and 20, 24. So we have 24 and 48. So 24 into 2 is how much? 48. Okay. So when we were calculating the ACF of 624 and 936, our ACF was 312. And the ACF of 312 and 264 is how much? 24. Because our remainder is 0 at this point. So therefore, ACF of 624, 936 and 264 equals to how much? 24. So this is how we find out the ACF of 3 numbers using this division method. Okay. So we'll cover the remaining topics in our upcoming live streams. Okay, today we have discussed ACF using prime factorization and continued division. Then in the upcoming live stream sessions we will cover lowest common multiple, LCM, and then we will discuss the relationship between ACF and LCM. Okay, so this is it for today's live stream, and thank you to all my viewers for coming in and joining in today's live stream and liking and sharing my video. This as soon as this stream ends, this video will get uploaded in my video. So in case you have missed anything, you can just go back to my channel, and in the live section you can get all the videos of today's live stream and previous live streams. So thank you so much for joining in today's live stream, and I hope you will support me in my journey of teaching. Thank you so much, and bye bye. Take care.